Okay, so I'm recording. As I said today, we're going to do section 1111. It's not going to take but 10, maybe 15 minutes. I'm going to give you a short program, and then I'm going to give you a bigger one. And the bigger one is one that you're going to hopefully finish during class. If not, wrap it up on your own and submit it. It's actually for a grade. So let's get moving along here quickly so we can get to all of that. Or do 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 do. Background music. Do 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 do. Do 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 do. Hey, where did we go? There we go. Days when the rains came down in the hollow. All right, both the books we use and pretty much every textbook that you use, you're going to see a section called enumerated data types. It's a short section. It's in there by itself, and we're going to go over it. There'll be a question or two on the final exam. Okay, final exam is going to be what we've covered since the last test. So there's going to be a couple of questions from it. So we're going to cover it. We checked it off when you go to your next class or next school and they talk about it. Did you cover this while you were at the community college? And you're going, yes, I did. So there. Because a lot of people think down on the community college, but we use the exact same textbooks they use. They're like, is Hacks Count good enough? We're using the same textbook. It's got to be good enough. All right, so today we're going to talk about enumerated data types. And I'm going to make, again, this is a new data type. Okay, we just covered structs, which was a new data type. So you see the relevance of why this is placed here. Another new data type. All right, this data type is called an enumerated data type. Basically what it is we use words to represent numbers. Oh, use words. I'm going to write that down. I like that. Use words to represent numbers. Feeling patriotic today. Look at all that red, white, and blue on here. Okay, so here is a simple one that you've been using and didn't even realize it. There's an enumerated data type called, and I made up my own, I call it boo, but what do you guys have? Boolean, right? You have Boolean. And Boolean is defined as a enumerated data type. It's got two values in here, okay? First of all, this is programmer defined. We're making this one up, okay? The enumerated data type says, hey, we can make it up. We can do whatever we want with it. And again, 162 is called advanced data types. You just keep making up more and more data types. And, like you learned in 121, we had objects when we're working with classes. That was a data type. Okay. You notice that the entries inside of this, and I like to call it set notation. The items in the set notation are strings without the double quotes. They're just straight up the word false. They're just straight up the word true. This is my list of identifiers. Okay. I have two identifiers. Some things that are going on. This false represents the number 0. This true represents the number 1. 0 and 1. Okay. I have another one down here. This is sort of like the one in the book. Here's an enum day. I have a new data type called day. This data type can hold the values Monday, Tuesday, Wednesday, Thursday. That's the days I teach class. Plus, I didn't want to keep writing Friday, Saturday, Sunday, so I stopped it there. So I have a new one. The preference is that the first letter be a capital. So I should probably make a boo be a capital. Down here I have boo as well. Okay. Now, something that's going on here, items in an enumerated data type have a unique predecessor and successor. We've seen that before back when we learned about switches, okay? In a switch, I couldn't do a switch with doubles. No, not going to happen. It had to be a unique, it had to be something that is a pred and a successor. Others examples are int. If I said the number 4, what comes before 4 in the integer world?
3,
3. What comes after 4?
5.
5. Right, you got the idea. Char. We know what comes before char. We know what comes after char. Boolean. Are you sure? What comes after false? True.
True.
Yeah, true. What comes before false?
True.
Yep, it wraps around. Okay, it wraps around. Just like in char, you get to that 255th character, the next one goes all the way back to 0. This is dealing off that ASCII chart. 0 is null. 0 is false. They all represent that same beginning idea. All right, so I can declare a variable of type boo. I call it torf. Some people think that's T or F. That's like Mork and Mint. No, torf gets the value of false. Again, no double quotes. Work gets the value of Wednesday. No double quotes. If I took this false and I did a C out on it, remember, these are names for numbers. These are names in the program in your code that's going to represent a number. And if I display it, I get a 0. If I display Wednesday, 0, 1, 2, it goes by its location inside of this set when I declared it. Couple of declarations. Day, work, I can give it the value Tuesday. I did something like that up there. What if I said int x equals work? Oh, all of a sudden x is getting the value of 1. If I see out, I get 1. The relational operators, they work as well. Why? Because these have a unique predecessor and it has a unique successor. Do you know what the word is for a unique predecessor and successor? That means these are, anybody? Anybody? Ordinal. It's called an ordinal data type, one that has a predecessor and one that has a successor. Okay, good. Couple of things out of the book. Ba-da-ba-ba-ba. Code listing 11.9. Here I have an enumerated data type called day, and you notice down here in line 16, I'm going from Monday to Friday. I'm going from 0 to 4. Less than or equal helps me because I don't have one after that. I'm going from 0 to 4. I can also use that down in here. This index is actually going to have a numerical value. Enumerated data type. Fun with enumerated data type. Here's another one. Do you notice I'm using subscripts? Instead of the number 0, sales sub 0, this might make it, what was my sales on Monday? What was my sales on Tuesday? So this is about the closest to relevance to writing code that's nice for somebody else to understand, but to use these to assign values. Otherwise, I've never used it in a program. Do 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 do. Here's another one. We go through and workday Monday, workday less than or equal to Friday, Wow. Static cast day. Whoo. Work day +1. It's just another way to step through. It's not that, exciting of a thing, but that static cast comes into play once in a while. And you'll see that down the road. Why he put it in here, I have no real idea. Last one's code listing 1111. Is this one you all had to type in? No? Nobody knows? Nobody knows.
I believe the highest we went was 11.9.
Okay. Yeah, I didn't think I made you type these in. It's not anything. Got my enumerated data type day. I declare a variable work day of the data type day. Work day goes through there using work day as subscripts. Okay. Here's where I wanted to get to, down here to this switch. Remember I said it's ordinal. If it's ordinal, I come in, if it matches Monday, again, none of these are in double quotes. My output is, because that has to be a string literal. So I have to put those in. Any questions on what an enumerated data type is? Okay, good. Good, good, good. Good. Good, good, good. And what did it take us? About 10 minutes, 12 minutes? All right. So under my notes, I'm going to put you in groups of, oh boy, one group of 3 and one group of 4. We can't do pairs. We can't do threes. Too many crickets. Okay. First program. Program. This is called coin combinations. Let's think of coin combinations. I have a penny. I have a nickel. I have a dime. And I have a quarter. That's all we're going to work with. We're not going to use half dollars or dollar coins. It would be easy to modify once you understand how this works. Input a dollar amount. Example, $1.63. Tell me how many ways I can get $1.63 using these 4 coins. How many ways can I get $1.63 using these 4 coins? Now, this is one of those where I would tell you to get paper and pencil because this part's the hard part. I could have 163 pennies. That's one way. Pennies. I could have 158 pennies and 1 nickel. Um, you know, I know how to solve this. I don't know why. Oh, it's 1 nickel, 158 pennies. That's a 1. Goodness gracious, I'm excited. I like this program. How are you going to figure out the number of quarters? Well, $1.63 is how many quarters? 6 quarters and then 13 cents. How do I get 13 cents? 1 dime, 3 pennies, 2 nickels, 3 pennies, 1 nickel, 8 pennies. So you're gonna, I'll just give it to you. Loop around, jump up, and jump down, loop around. Now I'm gonna give you about 15 minutes to come up with this. There are whiteboards in the breakout room. And I need you to possibly use the right whiteboards or something, but it's not a lot of code. So don't grab your computer and start typing unless your group says, hey, Nicodemus, why don't you start getting all the basics for a C++ program down, and then we're going to get in there and You know, you might want to create variables called quarter, dime, nickel, penny, and we know how much they're worth. While the rest of us are, you got the idea of what I'm talking about. Divide and conquer. Don't all just sit there and scratch your heads. Okay? Capiche? About 15 minutes. Go. Here we go. So, according to what it sounds like, your group was doing something like this. Your thought process was, well, if there's 2 quarters, I wouldn't need anything else for 50 cents. 1 quarter, 2 dimes, and a nickel. 1 quarter, 1 dime, 2 nickels, and 5 pennies. 1 quarter, 1 dime, 3 nickels. I mean, you got 1 quarter, 1 dime. Well, oh boy, you had lots of different ideas of what's going on here. And, this was grunt work, and you were working for exact values. Does that kind of sound right?
It's close to it.
Yeah. Group 2, what did you have going? Nicodemus, what did you guys have going?
Yeah, I was trying to sketch out like how to do it with a different value, which was $1.29, and it
Mhm.
was something similar. It was just like looking at the maximum number of quarters you could have, and then increment down and see how many pennies or dimes and nickels, and then move on to
Okay.
the maximum number of dimes, and then going down.
Okay. So, um, my first question is, what's the max number of quarters?
You'd have to divide by the input by 0.25.
Yeah, or, we could, excuse me, I could take this and multiply it by 100, so I'm working with 163. That might be a little easier. Excuse me. So, yeah, 163 divided by 25 is number of quarters. No more, no less, right? 6. How many dimes? What's the maximum number of dimes?
That would be the total divided by 10.
Yeah. And it looks like the max here would be 16. So taking on these maxes, which is a different approach than, grunt work. Clearly, you saw I was grunt working away as a possible solution, as something to show you. I also didn't go to $1.63. I went to 50 cents. Maybe I should have gone to 50 cents. No, I'm just kidding. Maybe I should have gone to like 35 cents and something smaller. And again, I'm looking for a pattern. I'm looking for, yeah, I can't really count all this up because next would be no quarters and a whole bunch of stuff. But am I getting patterns? Coming back to here, what if I would have said, yeah, the maximum number of quarters I can have is 6. The maximum of dimes is 16. What if I decided to go something like this? 163 pennies. I went from a for loop, the maximum number of quarters, boom, boom, and boom. I took whatever that counter was, then I had index, then I had I, and then I had J for pennies. Awful naming. I should have called it QUNIDI and PE. But do you notice I'm going to take whatever that current one is, do the calculation, and see if it equals my number. If it does, I add one to count. Okay. Thinking exercise. That's a thinking exercise. Again, is what you see in front of you efficient? Some of you folks were really focusing on the efficiency, but what if I had to do it quickly? There's sometimes 2 different worlds. This is quickly. This is going to be, oh my, 6 for the number of quarters times 16 times the number of nickels, which is 32, times 163 for pennies. So if you multiply those together, that's how many times line 29 gets executed. But we have computer speed. Does it take very long? Shouldn't. If I compile this, it should go bing, 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 and be done. How many combinations do you think there are? Take a guess. You guys are good at this game. All right. If I run this, I get 806. 806 different. So it's good you didn't try to write all 160 or 163, how many combinations there are. Because 163 of them were. Okay. Questions? Lots of fun. All right. Next one I want you to do. And I hope I didn't do this in another class with you. Well, you didn't have me, so but Sonnet 18 .txt. You're going to create a data file called Sonnet 18 .text. Now, where are you getting Sonnet 18? It is on D2L. Again, this is one of these where I want your group to get this done quickly. I want you to go to Sonnet 18. You can alter this as you're making this data file, but I want you to count the number, nice space, the number of each letter and display it. So your output's going to be 26. It's going to be the number of A's, the number of B's, the number of C's, the number of D's, etc.
Is lowercase a and uppercase a different?
Nope, they're the same. Yeah, this is just really, it bothered me. Count the number of each letter. Sounds pretty easy, right? I don't want to see 26 counters. I want to see an array of size 26. Makes sense? So in this, use an array. And I'll let you go from there. Modify Sonnet 18 data file as needed. You can just let it alone. So the Sonnet is on D2L. Grab it, make a text file in Notepad, then write so somebody could be doing this real quick in your group. And then I want you all to upload it. So one person from the group can upload it with everybody's names in it. So then I know to give everybody credit. I don't have to look at the same thing 3 or 4 times. Questions? Again, another programming, a little bit different. Instead of numbers, you're into characters and go in that direction. When you are done, we are done, and I will see you next Tuesday.